Hello everybody and welcome to another tutorial on the GED 2019 Kaplan series. Basically this is decimals and fractions, decimal basics. Okay, so let's get started here. Here's some key ideas. The decimal point separates the whole number from the decimal part. To round decimals, use the same numbers as with rounding whole numbers. Add zeros to the right of the last digit after the decimal does not change. Adding zeros to the right of the last digit after the decimal does not change the number's value. Just going to open something real quick so you can better see where my cursor is. Okay, so those are some key ideas there. Okay, so let's get started. Decimals are numbers that use place values to show amounts less than 1. You already use decimals when working with money. For example, in the amount $10.25, you know that the digits to the right of the decimal point represent cents or hundredths of a dollar. Okay, so the first 4 decimal place values are labeled on the chart below. So here we go. We've already learned, I believe it was the first video, lesson 1, basically to the left of the decimal point. Now basically to the right of the decimal point. It's pretty similar. The differences to take note are to the left of the decimal point, it starts with the ones place, okay? Then each digit over. So ones, tens, hundreds, thousands, okay? And they all end with the S, okay? Whereas to the right of the decimal point, it does not start in ones. It starts with tenths, okay? And you'll notice the ends are THS, okay? So tenths, hundredths, thousandths, okay? Which is different. Basically, these add THS, and the ones to the left only add S to the end of the actual word or number, the worded number. Okay, so let's see. But okay, back to this. Besides that, the numbers or the place values are still the same, like 10 and beyond. It's the same here as 10 and beyond. Tens, hundreds, thousands, 10,000s, okay, like that, 10,000s. Next would be 100,000s. This would be 100,000ths with the THS. Okay, the number 2.375 is shown on the chart. Read and in place of the decimal point. I read something wrong there. Okay, the number 2.375 is shown on the chart. Yep, right here. So read and in place of the decimal point. I'm not sure why there's a period there, unless I'm just reading it wrong. After reading the decimal point, the decimal part, say the place value of the last decimal digit. So let's see. After reading the decimal part, say the place value of the last decimal digit. This number would be read 2 and 375 thousandths. Okay, so let's see. 2 and 300. So 2 and 375 thousandths. After reading the decimal part, say the place value of the last decimal digit. So as you can see here, they say since this is the last decimal digit, you can see how they use the THS there. Okay, they don't use it anywhere else necessarily. let's see. So rounding. Round decimals the same way you round whole numbers. Example 1. A calculator display reads 3.62835. Round to the hundredths place. Look at the digit to the right of the hundredths place. So right here, so we have tenths, hundredths, that's the right of the digits place. Of the hundredths place. If the digit to the right is 5 or greater, round up. So we see that it's 8, so it's greater than 5. If the digit is less than 5, don't change the number. Then drop all digits to the right of the place you are rounding to. So for example, anything past the decimal point, like if it's a 0, say if it's the last digit and it's 0 and there's no other digits after it, then you could essentially drop that, because the a last 0 means absolutely nothing. Or if it was 10 last zeros, you could drop all 10 of them. But say if it was 10 zeros then a 1 at the end of that, then you couldn't drop them, because that 1 indicates that there's more to the value of the number. Okay, or for example, if this 8 was a 0, you couldn't drop from the 0 on, because it has this 3 and this 5 here, which indicates more value to this number. Okay, so the rounding decimal numbers is essentially the same as rounding off regular numbers. So as you can see here, what they did is, since 8 is greater than 5, you would basically round the hundredths here to a 3. Okay, and in a normal number or number to the left of the decimal point, say if there was no decimal point here, it would be 363. Then you would make these 3 digits zeros. Okay, so it'd be 3.63 if you were rounding it, then 0, 0, 0. But because, like we mentioned, decimal numbers, or numbers after the decimal point here, if they're zeros, they have no significance. It's as if nothing's there. So as you can see here, that is why they did not keep any of the zeros. They just dropped the zeros. Okay. Let's see. Comparing and ordering. Comparing decimals is similar to comparing whole numbers. Matt ran the 400-meter race in 45.8 seconds. Alonzo ran the same race in 45.66 seconds. Which runner had the fastest time? So line up the decimal points, add a 0 at the end of 45.8, so that both times have the same number of digits after the decimal. Okay, so that's what they did here. Funny thing, just to let you know about this, when I was actually doing it, I was looking over it before I did this video, and I accidentally chose the largest number. But when you're actually racing, you're trying to choose the smallest number, because whoever makes it in the least amount of time wins. So there's a little blunder that, if you're not thinking, you can make. Okay, so compare the decimal part of the number as though they were whole numbers. Okay, it says Alonzo's time was faster. So let's see, we have 45. We have 45 and 45. Both numbers have 45 apparently. So we move to the right of that. Okay. The next number is 8. This number is 6. So this number right after the decimal point, the first number after the decimal point will tell you the size of this number here, okay? Whereas that's not necessarily so with, numbers to the left of the decimal. It's first of all, it's the length of the number. If this has 3 digits, like if it had a 4 in front of it or 5 in front of it, and this one was simply 45, but this one was 545, we would know that this one up here would be larger, okay? But here, so that's not necessarily just the first, which number is larger at the beginning of a number, Whereas here, if there are only 2 digits, then that would be the case. If this was a 5, then we'd know that this is larger, this number 55 is larger than this. Whereas over here, it'll always be this first number here. No matter, even if there's 6, 6, 8, 5, 10, 12, 1000, whatever. As many digits as you add to this number, it doesn't make it larger, okay? It's simply the first number here that will decide, unless they're both, for example, 8. If this is 8 and this is 8, then you would go by the second number. Whichever one is larger, if this was a 6 and this was a 5, then we'd know that 8, 6 is larger than 8, 5, okay? So, in this case here, we would say that, see how this is, Alonzo's time was faster, even though, so Alonzo ran the same race in 45.66, Matt ran in 45.8. So the smaller number in a race is faster, so Alonzo ran it faster, okay? And now we are going to the next page. Okay. When you compare more than 2 numbers, it is helpful to compare one place value column at a time, working from left to right. Arrange the numbers 0.85, 1.8, 0.8, and 0.819 in order from greatest to least. Write the numbers in a column, lining up the decimal points. Add zeros so that the numbers have the same number of decimal places. Okay? As you can see, that's what they did here. Added some zeros so that they're just as placeholders, even though it does not make the number any larger. Okay? Compare the digits working from left to right. Only 1.8 has a whole number part, so it is the greatest. The remaining numbers each have 8 in the 10th column. So the 10th is right after the decimal point. All these 8s here, okay? Or here. In the 10th column, looking at the hundredths column, 0.85 is next, followed by 0.819. The least is 0.8. So, yeah, least is 0.8 right there. Okay, so round these numbers as directed. Round 3.75 to the 10th place. Round 5.908 to the ones place. Okay, these are actually separate questions or problems. So here we go. For rounding 3.75 to the nearest 10th place, There we go, 3.75, staying alive. So we know that this is, did it say nearest ones place? No, nearest tenths place. So this is the 10th. Okay. So, well, tenths place. So since this is 5 or greater, we know that we would get rid of the 7. Get rid of the 5 and change this to an 8. Okay. So 3.8. Okay. And remember, in a regular number pass to the left of the decimal point, we would need to put a 0 here. But because any zeros past the decimal point have no meaning whatsoever, you can just put 3.8. Okay. Now, round 5.908 to the ones place. So see how this has a ones or a S after it instead of a THS? So we know that it is to the left of the decimal point. Not only that, but to the right of the decimal point, there is no such thing as ones. Okay, it starts at tenths. So let me erase this here. Okay, so round 5908 to the ones place. Okay. 5.908. Excuse me. Okay, so 5.908. We need to round to the ones place, which is the 5. So we look at the number to the left. That number is 9. So it's 5 or greater, which means we would change this to a 6. And remember, in a regular number, we change this to a 6, and all the digits after would turn into 0. Okay? But since, remember, 0 to the right of the decimal has no meaning whatsoever, we can just leave it at 6, like this. Okay, so now we will look at number 3. Give me one sec. I'm going to check something out here real quick. I was just verifying in the answer key that they don't mind if we leave this just as 6 without the zeros, and that is correct. It's okay to leave it just as 6. Sometimes, GED has special expectations, so I just wanted to make sure I wasn't teaching you the wrong thing. Okay, so in a calculator display reads 0.4285714. Round to the nearest hundredth. Okay, so remember, a hundredth is, since it's TH, we know it's to the right of the decimal. So 0.428. Sorry, excuse my sloppy writing. I'm using a mouse for this. Okay, so to the nearest, what was it? Hundredth place. So remember, tenths, hundredths. So we know that the one to the right, which is thousandths, is 5 or greater. So what we need to do is 0.4. Since this is 8, we need to change this to a 3. Okay, so 3, and don't worry about adding anything else here because these would all become zeros, and zeros don't matter. Okay, the next one is number 4. Round 0.66667 to the nearest thousandths. Okay, so remember, tenths, hundredths, thousandths. Okay, so the one to the right of the thousandths place, which is 10 thousandths, is higher than 5. Okay, or I'll say 5 or higher because I should actually say higher than 4 because anything higher than 4 would have the same effect. So since it's higher than 4, we know that we need to change this over here to a 7. So what we'll do is 6, 6, 7. And since the remaining here would be zeros, we leave them off. Yeah, we can put the point here in the 0 if we so feel, if we so desire. Let me see one thing here. Okay, so next one is number 5. Round 8.125 to the nearest tenth. So remember, nearest tenth is ones place. Okay, so they're changing it up on us. What do you know? So since the hundredths place, which is the one to the right of the tenths, is a 2, so it is 4 or lower. We would turn these into zeros, the 2 and the 5, okay, and we would leave this at 1, so it would be 8.1. And we don't need to actually indicate that these are zeros since they mean nothing, so we would go 8.1. Simple as that. That would be your answer. And you may not understand necessarily why you don't have put the zeros there, but it's like this way across the board, so you don't necessarily need to understand, just get used to it, and then it'll become natural and make sense to you. So a calculator display reads 2.7142857, round to the nearest thousandths. Again, tens, hundreds, thousands. 4 is the nearest thousandths. So the one after the 4 is a 2, so it's 4 or less. So this would remain the same, and you could remove all of these here. Okay, again, if this number was to the left of the decimal, then you would put the zeros there, but in this case you do not. So this is thousands place. 2.714. That is your answer. Okay. Let's go to the next one right here. In each of the following pairs, which number is greater? Okay, so I have 0.45 or 0.449. Okay. This number here would be greater because starting from the right to the left to the right, we compare the numbers. 4, this one has a 4. Next one over, 5, and this one has a 4. Okay, so we know that 5 is larger than 4, so this number here is greater. Even though this has 3 numbers, okay, that doesn't really matter because it's after the decimal. If this was to the left of the decimal, a 3 a 3-digit number would be larger than a 2-digit number. Again, that may be a little hard for you to understand right now, but just know that in every case it's this way. Just start from the left to the right, and as soon as you hit a number that's smaller than a digit that's smaller than the digit in the same place of the other number, okay, then you would know that the one with the larger digit is greater. Okay, so then we have numero 9. Let's see, 4.68 or 4.068. So we have 4. Okay, we have whole numbers in both of them, and they're both the same, 4 and 4. Next one to the right of the 4 is 6. Next one to the right of this 4 is 0. So we know that 6 is larger than 0. Okay, so this is the greater number right here. Okay, 0.75 or 1.85. Well, this does not have a whole number. Okay, so this one does. So this is actually 3/4 of a whole number. Okay, whereas this one has a whole number plus some. So we know that this one is greater. Okay. Otherwise, if this was a 0, we would start with the number to the right of the decimal, which is 7. And this one is 8, so either way, this would still be larger. Okay, so 11, 1.0275 or 1.029. Well, let's do this. Both have a whole number. Next one is 0 on both of them. Next one after that is 2 on both of them. Next one after 2, this one's 7, this one's 9. So this number here is larger. Okay. Here, 0.14. Okay, well, we have 0, no whole number. So the one to the right of decimal is 1 on this one. Same here. Number 1. Then to the right of that is number 4. To the right of that is 0. So we know that this one is larger. Okay? Remember, as soon as you hit a smaller number, that number loses. Okay. Or shall I say, as soon as you hit whichever number hits a smaller digit first, that one loses. Okay, write these numbers in order from least to greatest. Okay, let's do this. So, again, just do the same thing. Whichever number comes with a smaller number first, okay, in the same place value. What I mean by that is the dot here, decimal. This is one place value. This after it would be another one. Then after it would be another one. Okay. So any one place value is like tenths. Okay. So anyone with a smaller place value, smaller digit in the same place value, tenths, 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 tenths. Okay. So you would compare those. Then you would compare hundredths, hundredths. Okay, only a couple of them have hundredths places. So let's see, but that doesn't matter because the ones without the hundredths, those are the ones that you would compare with the same place values as the ones with larger numbers or more digits. So 5.6, let's see. Well, I do believe that this would be the largest one right over here. So we have 5.802 as our largest number. Give me one sec here. Oh, are we supposed to put this in? Oh, right, in order of least to greatest. Okay, so we're not supposed to find the largest number. Regardless, this is the largest number. So you can see here both of these are even. This 5.8, again 5.8. This one has a few more digits to it, so that makes this one a little larger than this one. Okay, so let's just go ahead and do this. The smallest one is 5.08. Okay, let's put a comma to separate these. Second one is 5.6. Comma. Third one is 5.8. And the fourth one is 5.802. Okay, so that's the order. 5.08, 5.6, 5.8, 5.802. And you can see why by counting or looking at digits in this order. Okay, seeing which one has a smaller digit first, which is this one, has 0. Okay, this one's next because it has 6, whereas these two have 8s, so on and so forth. Okay, let's try the next one. So here we have 0. Okay, we're supposed to do smallest, so 0.11. This has 0.12. 0.2. This also has 0.11, but it has a 5 versus 0.113. Okay, so 0.1136 would be your smallest one. Okay, I'm not going to write all these down because they take a little while. So we have this one is the smallest. Okay, next smallest is this one here. It has 0.11. Okay, whereas this one has 0.12. Okay, we only compare the larger digits versus the quantity of digits. Okay, unless they have identical digits, then the one with the larger quantity wins. But this one here has the 2, whereas this one has 1, so the 5 does not matter. If this had a 2, which it does, and this one as well had a 2, then we would count this number as larger because it also has a 5. So this is the smallest number, this is the second smallest number, this is the third smallest number because it's 0.1, whereas this one's 0.2, and we know 2 is larger than 1. So this smallest, next one's this, next one's this one here, then this is the greatest. Okay, so in this case, following the same idea, we have 14. Okay, this is the largest because it has 2 whole numbers. So between these ones here, this has a 5. They're all these whole numbers are the same. So move to the right. This has a 5 after the decimal. This has 8. This has 6. So this would be the smallest because it has a 5. This would be the next smallest because it has a 6. This one would be the next because it has an 8. And then this would be the largest. So it would be in this order. This one's smallest. Let me do this. This one's smallest. This one's next. Then this one. And then this one. Hip hip hooray. Okay, last one. Okay, these all have 0 for the whole number, so no whole number. They also all have 8 in the tenths place, so to the right of the 8 is 0. Okay, wow, let me see. This here would be the smallest, okay, because they all have 8s in the tenths place. And this has no more numbers, whereas these do. So this is smallest. Then 80. Comparing it with these two, yeah. So this would be the next smallest. Then this one, okay, and then this one here. Alrighty then. Choose the one best answer to each question. In circuit board assembly, the weights of 3 parts are 0.572 grams, 0.0785 grams, and 0.6 grams. Which of the following lists the weights in order from greatest to the least? So first you have to figure out which one's the least. So even though this has fewest digits, it's the greatest number, because right after a decimal it has the largest number. Then this one, which is the 5, and this one has 0, so we know the smallest. So here, so A, list them from, oh, did it say greatest to least? Yes, greatest to least. So this one here has them in the correct order, greatest to least, which is number C, or letter C. 18. Which of the following correctly shows 1.3815 rounded to the nearest hundredths? So remember, this is hundredths place, and the one after hundredths is below 5. So we would round. Essentially, these would turn into zeros. 1 and 5 would turn into zeros, which is not required to show. So this would be your answer here, 138. Anyways, that's the end of that lesson. Thank you guys for bearing with me. Hope you learned something. If you have any questions, please leave a comment. Be glad to answer it for you. If you like this, please subscribe, like, share if you know anybody that is going through the GED, and stick around for lesson 7. Thank you very much.